Okay, I wanna give the lecture of the remaining part of section 6.3, the orthogonal projection, because I didn't finish this lecture today. Let me see here. I explained everything today, and then I'm gonna go over the slide 10. Here, the best approximation theorem. What's that? So we have this one. Let W be a subset of Rn. Let Y be any vector in Rn. Let Y hat be the orthogonal projection of Y onto W. The Y hat is the closest point in W to Y, in the sense that the norm of Y minus Y hat is less than norm of Y minus any vector V. So for all V in W, distinct from Y hat. Here, this is like a graph is like this. So what's like Y hat is called the best approximation to Y by elements of W. The Y hat is the closest point in W to Y. The distance from Y to the subspace W is given by this is shortest one, the norm of Y minus Y hat is exact the distance from Y to the subspace W. Okay, I'm gonna explain this one by using another like whiteboard. Here. What's that? I can just show something to you here. So we have the one plane. So we have the one plane here. One plane. This is like W is given. So this is like point zero. Like some the zero vectors here. We can draw vector Y. Vector Y is like this, vector Y. So I'm gonna project vector Y onto subspace W. So what happens? So we have like this. Just only project onto vector W. This is like exactly right angle and connect this one. This red one is exactly Y hat, the Y hat. This is like the best approximation. This is the best approximation to Y. The Y, I can show to you. So this one is like, what is it like this one? So one more. You can choose another vector, the V on here, another vector V in here. I can use another color. This vector is vector V. So what's like a distance between vector Y and the vector V, vector Y and the Y hat? So let me see. You can connect this one to the here. Like this. So you can then make a triangle. So here we can use, so here, what is this length? So this length is exactly the y minus like v, so length is the vector y minus vector v, is like this length. So what is this like blue one? This blue one is exactly the norm of vector y and the y hat. So vector y minus y hat, like this. So what's that? So what happens with this kind of things? You can think about it. You can connect one more things. I can use, what's that? This is like gray one. Here, connect this one, this gray one. Here, this is also right angle. So what's it like this length? This length is so same to the y hat minus v, is right? This is y hat. The y hat minus vector v, like exactly this length. What happens? This is like exactly the shortest one. So this is y minus v is greater than the y minus y hat, right? So how do you know that this kind of things that we can prove? The proof is like this. It's like a proof. So we think about vector y minus vector v, exactly same to the vector y minus y hat plus y hat minus vector v, the same. You can take norm, this kind of things, and make grouping. You can make the two groups. The first group is this one. This is like make a second group, so like this. The next scale both sides. Scale both sides. So what happens? This is aimed to like this. This is aimed to here. Y hat minus this one plus vector v, the dot product. Same things. Vector y minus y hat plus v. You can use the FOIL rule. The FOIL rule. You can the FOIL. So what happens? Exactly y minus y hat, the dot product minus y hat plus inner outer the 2 times y minus y hat dot the y hat minus vector v plus y hat minus vector v dot product y hat minus vector v. So what happens? This is same to vector y minus y hat here. So what's like this one? The y minus y hat is y minus y hat. What's y minus y hat? The y minus y hat is like this blue one. The y hat minus v is exactly gray one. What happens? This is like a right triangle. What does it mean? Orthogonal. This is like orthogonal going to 0 because it's 2 vectors orthogonal. And plus remaining part is norm of the y hat minus vector v, the square, same to this one. Like this. So one more. The y minus y is like a non-zero vector. The y hat minus vector v is also non-zero vector. What does it mean? So this is always greater than 0. So what's that? This is greater than only this one. Like this. So we have y minus any vector v square is greater than the y minus y hat square. The next, you can eliminate square, just take a square root. Take a square root. So 2 is gone. What's like a final answer? The final answer is like this. Norm of vector y minus vector v is greater than norm of vector y minus y hat. So that's it. So what does it mean? This is shortest distance. So this is best approximation. This is the whole idea from the previous theorem. Okay, we are going back to here. So this is true. So next, I'm going to give some examples. So this one. Find the closest point to y in the subspace W spanned by V1 and V2. So how can you find the closest point? You can find y hat. The y hat is like the closest point from the previous examples, right here. The y hat is the closest point. This one. So how can you find the y hat? So you can use this one. How can you find y hat? So y hat is exactly the vector y dot product vector v1 over vector v1 dot vector v1 and vector v1 plus vector y dot vector v2 vector v2 dot vector v2 and v2. What's y dot v1? 3 times 1 is 3. Minus 1 times 2 is positive 2. 1 times minus 1 is negative 1. 13 times 2 is 26. Over v1, v1, v1 dot v1. The 1 times 1 is 1. The negative 2 times negative 2 is 4. Negative 1 times negative 1 is 1. 2 times 2 is 4. And vector v1. 1, negative 2, minus 1, 2. Plus, here, y dot v2 is 3 times minus 4, is right? 3 times minus 4 is negative 12. Minus 1 times 1 is minus 1. 1 times 0 is 0. The 13 times 3 is 39. Over. The v2 dot v2, negative 4 times negative 4, 16. 1 times 1 is 1. 0 times 0 is 0. 3 times 3 is 9. So we have the v2, the negative 4, 1, 0, 3. So we have it. And simplify. So 3, 2 minus 1 is like 4. 4 plus 26 is 30. 30 over 10 is 3. 3. The 1, negative 2, minus 1, 2. Here, 12 minus 1, the negative 13. Negative 13 plus 39 is 26, right? 26 over 26 is just 1. 1 times negative 4, 1, 0, 3. And add it. What's that? 3 minus 4. The negative 6 plus 1. The negative 3 plus 0. 6 plus 3. The final answer is the minus 1, negative 5, negative 3, 9. We have this answer. This is like the closest point to y in the subspace W. The second one, find the best approximation to z by vector of the form C1 V1 plus C2 V2. How can you find the best approximation to z? Like same, z hat. We can find z hat. Or like Z hat, so Z hat is the same. So exactly the vector Z dot vector V1 over the vector V1 dot vector V1 plus vector Z dot vector V2 dot vector V2 and V2 and calculate. The G times V1, 2 times 2 is 4. The 4 times 0 is 0. The 0 times minus 1, 0. The minus 1 times negative 3 is positive 3. Over, what's V1 dot V1? The 2 times 2 is 4. 0 times 0, 0. The negative 1 times negative 1, positive 1. The negative 3 times negative 3 is positive 9 of V1. So 2, 0, minus 1, negative 3. Plus the GV2, 2 times 5 is 10. The 4 times minus 2, negative 8. 0 times 4, 0. Minus 1 times 2, negative 2. Over the V2 dot V2, the 5 square 25. Negative 2 square is 4. The 4 square is 16. 2 square is 4, like V2. The V2 is 5, negative 2, 4, 2. So we have it. So what's that? You can calculate. This is 7 over 14. The 7 over 14 is 1 over 2, right? We have 1 over 2 and V1. V1 is 2, 0, minus 1, negative 3, plus 0 times vector V2, 5, negative 2, 4, 2. Right? This is like the answer. So why is this is true? Because the V1, V2 is orthogonal, is right? So you really be careful. The V1 dot V2, you can calculate this one exactly 10 plus 0, negative 4, negative 6 is 0, exactly orthogonal. This is like orthogonal space, so we have this answer. This is not orthogonal, though we cannot express. We cannot express. This is very important. The previous example is saying the V1 and the V2 is like orthogonal. U1, U2 is orthogonal. You can use this kind of expressions possible. The next example here, the same. You can check. The vector V1, V2 is orthogonal 1. Vector V1 and V2, what's that? The 1 times minus 4 is negative 4. Negative 2 times 1 is negative 2. Minus 1 times 0 like 0. 2 times 3 is like 6. Yes, it's orthogonal. So you can use this idea. The first one, you can find y hat. The y hat is, what's that? Same. Vector y dot vector v1 over vector v1 dot vector v1. And vector v1 plus vector y dot vector v2. The vector v2 dot vector v2 and v2. So first one, y times v1, what's that? 3 times 1, 3. Minus 1 times minus 2 is positive 2. 1 times minus 1 is negative 1. 13 times 2 is plus 26 over v1 dot v1. 1 times 1, 1. Negative 2 times negative 2, positive 4. Minus 1 times minus 1, positive 1. 2 times 2 is 4. And vector v1, 1, negative 2, minus 1, 2. Plus y dot V2, 3 times minus 4, negative 12, minus 1 times 1, minus 1. 1 times 0 is 0. 13 times 3 is 39 over the minus 4 square 16, 1 square 1, plus 0 square 0, 3 square is like 9, like -4, 1, 0, 3. Then calculate. So what's that? You can calculate. The calculation is exactly same to sample. So you can calculate. Answer is the -1, -5, -3, and 9. We have this one. We have it. The next tip. You can find the distance from Y to the subspace R4. So what does it mean? So you need to calculate vector Z. Vector Z is like vector Y minus projection Y hat. The vector Y is here. 3 minus 1, 1, 13. Minus Y hat. The Y hat is here. So -1, -5, -3, 9. And calculate. What's that? This is 3 minus 1 is 4. The -1 minus 5 is 4. The 1 minus 3 is 4. 13 minus 9 is also 4. So we have it. So next, you can find distance. What's like distance? Norm of y minus y hat. It's like exact distance. The square root of the first entry 4, the 4 square plus 4 square plus third one 4 square plus last one 4 squared. So this is same to the 4 times 4 square. The root 4 is 2. The root 4 square is 4. So we have 8. This is the final answer of this question. Okay, so thank you for watching my lecture video. So you just only, if you have any question, any trouble, please let me know. I can help you. Okay, thank you.